And I say Luz Lanzarote came. You have lots of people that came to listen to you, Peggy. This is so great. Okay, folks, welcome everybody. I'm going to share my screen in a second to talk a little bit about SHIELD and introduce our speaker. I wanted to thank Peggy for coming and talking to us. Her journey is quite incredible. She was one of the 3 women to sign up for College of Technology in '54 at UNH. And I am really, she has a stellar career that started a cosmic race, and she got lots of accolades. I'm going to let her tell her story. Before that, let me just share my screen really quick and go briefly so we don't take too much of time of Peggy and for questions. Welcome to the SHIELD webinar. This is supposed to be a very informal setting. I bought my coffee. I hope you guys brought your particular beverage to sip with us. I'm Merav Ofer, the PI. This is one of the 3 drive centers that were funded for Fully Center by NASA. John Richardson is in MIT, the program manager. We are online, have Dr. Sanlin Buxner. She is the Director of Outreach, and Dr. Nick Ross, the Deputy Director of Outreach. And I'm going to start by showing you a movie that we created for SHIELD that show the importance of the heliosphere. So right now we are embedded within this big bubble that protect us and that enable life to form. And you can see the sun, the planets, and one of the goals of SHIELD is to understand this bubble and its connection with why do we exist here in this one, the only case that we know of inhabitable bubble, a habitable astrosphere. Today this is a webinar, like I said. The vision of SHIELD is to create a model and an understanding, theoretical, and be able to understand the data that describe the heliosphere. You can check out our new website. And it's centered around 4 questions. What is the global structure of the heliosphere? We still years, decades into research on heliosphere, don't even know the shape of the heliosphere. We would like to know that. We don't understand completely how pickup ions that come as neutral hydrogen from the galaxy affect the solar wind, how they evolve until they leave the system and as energetic neutral atoms. We would like to understand how far the heliosphere affect interstellar medium ahead of it, and how cosmic rays, and this is coming to Peggy's research, how cosmic rays enter, filtered, and transported in the heliosphere. We do have data from Voyager spacecraft that tell us that the heliosphere shield 70% of the cosmic rays, but we don't have right now a predictive model that we're able to tell even astronauts that go to the moon or to Mars the level of radiation on different points in space and in time. So this is one of the goals of SHIELD. Lots of institutions involved. Again, go to the website, you will see more about it. We also have a really strong outreach and broader impact. And here we try to mimic the heliospheric current sheet here with all the different activities that we have. One of them that are very dear to my heart is the testimonials, where we ask grad students in early career to tell about their experience. And the idea behind it is to create a mosaic of different faces and experiences for space physics. So if you have a grad student, you have an early career, it doesn't have to be in outer heliosphere, it can be in any field that would like to take part of it, please email SHIELD Outreach or any of the broader impact team, Sanlin Buxner or Nick Ross, or myself even. We will have the next event, Maura Hagan is going to talk in March 17, and then Linda Elkin Tanto is going to talk in April 21. about their career and their challenges and opportunities. There's another thing, if you have students in both undergrad, and early careers, we have a coffee chat that is run by Sandin and Nick, and none of the PIs are invited, so they have a safe space to discuss mentorship, their career, the struggles, and create a community. The next one would be on Friday, January 27. So without further ado, I will pass it to Peggy. You can find us in several social media, both in our website, Facebook, Twitter, our email, and after Peggy tells us about her career, we will open for questions, both from me, both from you guys, and I'm looking forward. So I'm going to stop sharing.
Well, thank you very much, Marat, for that excellent and flattering introduction. And I want to thank you and John Richardson for inviting me to present this seminar. I grew up in Portsmouth, New Hampshire, which happened to have an excellent school system. My first recollection of an interest in science was actually in the 7th grade. I had a very good science teacher, and I remember coming home and telling my parents, I have a subject in science. I've never had this before. It's interesting. My father was an electrical engineer, and my mother was an elementary school teacher. And I would like to mention right off the bat that they encouraged me in just everything I did. They always challenged me, but they always encouraged me. My first indication of bias toward women in science was actually in the 8th grade. Our high school at that time had 2 options for college, for students who were intending to go to college. One was called college academic, and the other was called college scientific. I had to make a selection when I was in the 8th grade, and I selected college scientific. The guidance advisor at that time then called me aside and said, "Why, Peggy, I would have expected you to sign up for the college academic section, not the scientific." I was probably too young. I was only 12, and I was probably too naive to even realize that this was some type of discrimination. I just shrugged my shoulders and said I like science, and that was it. And I went on to the college scientific high school education. I entered the University of New Hampshire, the College of Technology, in 1954. There were 3 women in the freshman class in technology. There were no women professors, either in physics or in math. During the spring break in 1956, I was hired as a data technician at the whopping big salary of 90 cents an hour. We were preparing for the International Geophysical Year, which started in 1957. And my job was to help record the cosmic ray data intensity recorded by 2 neutron monitors, one located in a truck on the UNH campus, and the other one located at the Mount Washington Observatory in upstate New Hampshire. Data were recorded in 2 ways: on analog charts, as you can see here, and this probably looks very primitive to people of today's generation, and also by a camera which filmed the counting registers, which was a cumulative counting rate. My job was to go through the film, write down the cumulative counting rate each hour, then subtract the numbers to get the hourly counting rate. Finally, using an adding machine to obtain the daily averages, we plotted the cosmic ray intensity every day on plots similar to this, and these were stretched all over the office as we kept track of the cosmic ray intensity. This was pre-IGY, and the IGY started in July 1957. I was then hired to do the same data entry work during the summers of 1956 and 1957, as well as working 10 hours a week during the school year. My salary was increased to $1 an hour. Once the IGY started in July 1957, we had made by hourly counting rates. These were calculated from the hourly counting rates because this was the prescribed format for the International Geophysical Year. The data were then typed by hand and then sent to the World Data Center in Belgium. Now, the cosmic ray group was a friendly group. We readily exchanged our data with other members of the scientific community. At times, scientists requested hourly data, and since they weren't at the World Data Centers, these were personal requests sent between different PIs in different locations, and we would honor those requests by doing the hourly counting rate from those that I had calculated just earlier, and do them out in handwriting. This is an example of just one event where I was asked for the hourly data, and I wrote it out by hand and then sent it out to whoever requested it. Mount Washington is known for bad weather, so another one of my duties was to contact the weather station on the summit by radio to obtain their daily counting rate reports. They would check the neutron monitor twice a day and then send down the information by radio telephone, and I obtained a radio operator's license to do this. We did this, we contacted them once a day, including weekends. In the mid-1950s, physics was considered a pretty dead subject, but all that changed in October 1957 with the launch of Sputnik. Since I had been working part-time doing essentially grunt work in cosmic radiation, I was finding it interesting. I was learning along the side, and I decided that a career in space science would be my goal. After graduating in 1958, I received a research assistantship at the University of New Hampshire while pursuing a master's degree. I was the only female graduate student with a total of 7 graduate students in physics. The 6 men started to play jokes on me. First, they moved my desk from the basement to the 3rd floor of the building. I sputtered about that, but got the janitorial staff to move it back and kept relatively quiet. I thought something else would be happening next. It was. Then one day, a couple of them rushed into my office with a hose wrapped around a long, long rod, yelling, "Snake, snake." I looked up and I said, "What kind?" After that, I became one of the boys and was nicely treated. They didn't realize that unless that snake had a rattle on the end of it, I wasn't going to get very worried about a snake. The same was true with mice. In 1961, I met the 2 most influential individuals who have supported me in my career. One was Dr. Dennis McCracken, and you can see him here over on the left. Oh, go back here. This picture was taken in Mysore, India at a Coast Guard conference in 2012. Ken was doing a postdoc at MIT, along with actually U.R. Rao, who is on the right side, who eventually became the head of the Space Science Department program in India. And here we are all reunited back in Mysore in 2012. Ken was interested in solar proton events, and it so happened I was writing my master's thesis on the solar proton events that occurred in November 1960, and that is the data from the Mount Washington Neutron Monitor. So Ken and I had a shared interest. Ken had developed a digital computer program to trace particle trajectories of particles of charged particles in the geomagnetic field to determine the geomagnetic cutoff rigidity of locations on the Earth. where cosmic ray detectors were located. The Earth's magnetic field shields the Earth from cosmic radiation, the amount of shielding being a function of location, latitude and longitude, mostly of latitude. The computer program also calculated the direction in space from which the particles entered the magnetic field. This was all new and exciting work. The technique Ken developed and the applications which I later developed are still being used today. I had taken a course in computer programming and I was anxious to try this program. I was using a IBM 704 computer at MIT. I had learned both machine language and then later Fortran. Ken graciously gave me a copy of his program to use. That was when I met the second person who was influential in my career. My assistantship was funded by the United States Air Force, and the contract monitor was at Hanscom Air Force Base in Massachusetts. I contacted this individual requesting computer time on an Air Force computer to do the calculations I needed for my thesis. He became interested in the entire problem. We spent considerable time at both the MIT and Air Force computers. And so I would bring a program down. We'd start it at the MIT computer. We'd go out for dinner at the Joyce Chen's restaurant at Fresh Pond. Some people may still remember where that was. Then go back, pick up the results, and set up another computer run. As many of you know, this was Don Smart, and he later became my husband. He has supported me throughout my career. In 1964, I became a civil servant working in the Cosmic Ray Group at the Air Force Cambridge Research Center, working alongside Don. Now, one cold February evening, we were discussing a scientific problem passed along to us from Hugh Carmichael of the Atomic Energy Commission, another cosmic ray physicist, and he lived in Canada. Was there any place in the United States where he could put his mobile cosmic ray monitor to measure the cosmic radiation at sea level, altitude, and having a high geomagnetic cutoff? The only place I knew of was on Maui in Hawaii that was within the United States. Within 3 months, I was the U.S. liaison on a latitude survey that included extensive measurements on the West Coast, and you can see it by the blue line here. And then we moved the equipment to Hawaii and eventually on to Maui. The laboratory even arranged to have the Los Alamos Flying Laboratory, 707, operate the neutron monitor equipment at different altitudes from 10,000 feet to 40,000 feet at 3 different locations, Mount Palomar, Mount Hood in Oregon, and also at Haleakala on Maui. This research project led to several publications. I was 28 years old, and I was thoroughly enjoying my career in space science. Now, 1966 was an extremely busy year. I had either authored or co-authored 3 AGU presentations in March, 1 APS presentation in April. I did the latitude survey, which was actually encompassed 3 months from the middle of May and toward the end of July. I had 2 presentations at a symposium in Yugoslavia in September. I was busy. But that wasn't the most important thing in 1966, in my opinion. The most important thing was my marriage to Don Smart. Now, I'm going to digress a bit here. And this is the importance of having goals. In high school, I made a lot of my own clothes. And I once mentioned to my mother that if I ever got married, I would make my own wedding gown. So in spite of the busy year, I both designed and sewed my own wedding gown, and that was a goal achieved. My mother thought I was really very ambitious to do it. She had my doubts. She had doubts I would be able to do it, but I was pretty determined. I wanted to reach that goal, and I did. And I had no pins left in that wedding gown. Now, In 1971, I presented a paper at the IGY meeting. The idea of this was to take the asymptotic directions in the cosmic ray trajectory program and determine the directions in space from which high energy particles would come before intersecting the Earth's magnetosphere. After a session, after I made the presentation and during the coffee break, a well-known scientist approached me and said, "It will never work." And then he walked off. 3 years later, he was using that technique to do exactly what I had predicted. A few years later, I noticed that the geomagnetic cutoff rigidity that we have been calculating was decreasing at locations in South America. We were using different forms of the configurations of the internal geomagnetic field, which were being determined every 5 years by a group in Yaga. I wondered if the effect of the decreasing geomagnetic field was sufficiently large to result in a measured increase in the cosmic radiation at those particular locations. Dr. John Simpson had a neutron monitor located in Huancayo. He heard the paper, and after the presentation, he came to me and said he was skeptical, but he would take a look at the data and see if he was seeing this particular effect. A few years later, he reported that the intensity had indeed increased at Huancayo as I had predicted. In 1976, there was a neutron monitor that was in operation on an aircraft flight from Johannesburg, South Africa, to New York. But the counting rate shown at the top of this slide, when plotted against our 1965 cutoff rigidities, resulted in an inconsistency. The principal investigator in South Africa, Peter Stoker, contacted me and he said, "I don't understand this. Can you help us out?" We recalculated the cutoff rigidities using an updated model of the geomagnetic field for actually the time of the flight, 1976. That's a 10-year difference. When we did that, we found that the intensities did converge. Now, these are examples of people from different organizations and nations working together to solve a problem. It is also an example of something I have always advocated, and that was believing the data and then letting the data guide you to the next step in the scientific process. Throughout this time period, I was active in several international programs. These were programs organized by various organizations such as COSPAR, IUGG, Yaga, and the IAU. Working on these programs and attending the various workshops and scientific meetings was extremely valuable to me on many occasions. I met a lot of scientists. Fortunately, the work I was doing was basic research. It was all new because space was really still new in the 1970s. The results often led to publications, and I was asked if I would help edit some of the papers. And this is how I have ended up as an editor of several publications, and including my stint as 15 years as editor-in-chief of Advances in Space Research. I'm still a co-editor and now doing just special issues. So to summarize, we knew very little about solar proton events in the 1950s. If there was a big flare on the sun and it was toward the west of the sun, probably would have a big particle event, and that was it. Now space came into play, and during the 60s, 70s, and 80s, our knowledge increased over the years as space was explored by both satellite and ground-based measurements. By the time we got to the 90s, there was certainly a lot to consider, not only the various things that were being measured and detected, but the accuracy, the confidence, and the false alarms if we were trying to predict anything. It certainly became a solar terrestrial physics problem to solve. This led to my involvement in the forecasting of the space environment. called space weather today. By this time, I had successfully merged my research in cosmic radiation and the asymptotic directions into my continual increase in the high energy solar particle events. So the transition into space weather was a logical step ahead. Since space weather involved a combination of theory and experiments, and as I considered myself an analyst, I just started utilizing a different type of graphics in my presentations, which were both at engineering and scientific conferences. For example, I used this graphic to tell the story of how the province of Quebec, Canada, lost its power grid during the geomagnetic storm in March 1989. I had a graphic of the story of the collision of two trains in Western Canada in February 1986. It was questioned if the geomagnetic surge had caused a malfunction of the train signals. And as you can see, I have the scientific part, the KP values, and that's some geomagnetic field values, right at the point where the two trains were headed toward each other. There was actually a court case on this in Canada. I knew one of the scientists who had testified, and they could not show that this was the cause of the collision. Finally, the most interesting one of these to me, was during the Olympic Games in 1994, when spacecraft charging on a relay circuit caused a 60-minute telemetry outage in Japan. Just at the top of the top Japanese ski jumper, Harada, was jumping for the medal. All the televisions went out in Japan right at the time he was jumping. They were out for 60 minutes. I used this picture in the talk in Japan, and everyone started laughing even before I got to my oral presentation of what was happening. They all knew what had happened. I retired from the Air Force Research Laboratory in 1997 after 32 years of being a not so civil servant. But I had one more goal to achieve, and that was a doctor's degree. Over the years, we had extensive work with the University of Tasmania in Australia. At the suggestion of Ken McCracken and Dr. John Humble, Dawn and I both enrolled in their graduate school. Each of us wrote our individual dissertations. And 40 years after I had my MS degree from UNH, I received a Doctor of Science degree from the University of Tasmania. And there you can see both of us. In reviewing my career from the IGY to the present, I realized I have been extremely fortunate to have been in the right place at the right time. I was supported by my parents and my husband, as well as many others in the cosmic ray community and the solar terrestrial physics community. To the young scientists who may be participating in this webinar, I would like to say that there may be bumps along the road. I certainly encountered many of them, which I have not bothered to detail here. I've mentioned a few of them, people who decided that my presentations really weren't going to work out. Sorry, fellas, they did. These goals that you may have may change in time, but having a goal will have you focused on the road ahead, and then you will eventually achieve your dreams. And with that, I will turn it back to Murat.
Fantastic, Peggy. I loved it. Do you know that I have a quick comment, and then I have a question, and then we can open to other questions. You know, I love I haven't seen your slides before, so I love this old, especially the one that you showed at the beginning, the neutron monitor counters. And I love when I entered into space physics, seeing the old VAX machine in the Jet Propulsion Lab, Voyager, and I'm a daughter of an astrophysicist, and I remember still going with him to the old machinery. That actually inspired me to enter the field. So it was super, super fun to see that. Peggy, I had a general question. And one of, you might have seen in some of the webinars we did in the past. I'm also interested in how you approach science in general. One approach science, the different minds, how they approach. I remember talking to Nancy Crooker, and she's very visual. And I consider myself very visual. And so you go with a more intuitive way to approach, and then you go after the equation or the physics. It's kind of it's a backward process. You go your visual intuition, and then you search for the phenomena in the equations that you're used to. And rather than a lot of the physicists go to the equation and then, so I read that you also were very interested in journalism and in high school, and I see now you're showing a lot of the graphics you used. So I was wondering how your interest in maybe storytelling or journalism influenced the way you approach science, or how you came not just communicating the results, but even thinking about them, kind of gauging your own intuition.
Well, this is interesting, and thank you for the question. I studied geography in the 4th grade, and the war had ended, and my parents took me on a car trip to visit relatives in North Dakota, and then we went through national parks, and I was fascinated with geography. And at the tender age of 9, I was going to be a geographer. Then in 8th grade, 7th and 8th grade, but in 8th grade in particular, there was a teacher in science who had a whole section on astronomy, and I loved it. And I was going to become an astronomer. The next thing was in my junior year in high school, I should probably backtrack a bit. The senior student was always selected to write a newspaper column for the local newspaper of school activities. So what happened was that I was a junior. I just entered my junior year, and I casually said to my father and mother, maybe when I'm a senior, I can do that. And my father said to me, why don't you apply for it? And I said, I'm a junior. I can't do that. It's a senior. He said, apply anyway. So I did, and I got it. So for 2 years, I wrote a column for the local Portsmouth Herald, and I was paid 10 cents an inch. Now, students love to have their names in the newspaper as to what they're doing, joining this club or that club. And so at that point, I added lots of names to get my 10 cents per inch. That was newspaper inch. So that had my interest in journalism. Now, I do come from a father that did very well in writing. He was a winner in Massachusetts for the entire state of a composition that he wrote back in 1927, I believe, 27 or 29. And it was 29. And so there is some genetic probably that came along with wanting to write. I thought I might study journalism, and my father, who was an electrical engineer, said, no way, I don't want you studying journalism. He said, get a career in something else and then go back to journalism if you're still interested in writing. And I am still interested in writing. In fact, I have another goal. I would like to write a book. But
Fantastic.
It won't be a book about science. It'll be a book about my career.
That would be an amazing thing to do. Yeah, we need that. But you think it's informed you, the way you look at the data in a way that you were trying to tell a story? That was actually was behind my question.
Yeah, so I have heard that needlepoint is something that Peggy is really interested in, and I would love to hear more about how that kind of plays into her life and her interests.
That's great. Peggy, I see Peggy back.
Oh,
that is great, Peggy. Peggy, we were
I'm
waiting
back,
for you.
I don't have the video again because the host has stopped it. I have no idea what happened. Blame it on the weather.
Blame on the weather. So Peggy, our director of outreach, Sanlin, was asking how your needlework play into your research. And Sanlin, you can ask more if you want.
Oh, how did my needlework work into that? I have two hobbies. One hobby is doing needlepoint. Now, again, I mentioned I learned how to sew when I was in actually 7th and 8th grade. And I do crocheting and knitting the whole bit. My mother taught me a lot. And then I decided to do some needlework, and I'll see if I can share the screen again. I will have one picture that I had on there. There it.
Double click on that
That's
slide.
that's the needlepoint, right? That's one of mine. I did of the Golden Gate Bridge. I've done about somewhere around 80 or 90 of these types of mostly figures, but I've done some sayings also. I find it relaxing to do this type of work. And sometimes I'll just sit down in front of the TV and watch the news. And I don't always have to listen to look at what the screen is. I can work on the needlepoint. It's relaxing to me, and it gives me a chance to do a little designing, which I enjoy doing also. My other hobby is photography. And I think I try this one. Was a picture that I took in Alaska. I happened just to see the eagle sitting there and stopped the car. My husband and I had taken our car all the way from New Hampshire up to Alaska. I intended, and we did, drive all the way to Prudhoe Bay and back, and did a lot of photography, except it was very smoky that year because of the forest fires. But we opened the sunroof on the car and just sat there and clicked away at that beautiful eagle. I enjoy wildlife and scenery pictures, and some of the ones that I showed you, that bumpy road, which is a road in Maui, and the other one is a road out west somewhere. I'm not exactly certain, remember where it was. Those are all pictures that we took. I took most of those.
Fantastic. Peggy, we have a comment from Rebecca Jolitz really saying that she's
she can
yeah.
I invited her up to talk so she can express that.
Right.
Oh, thank you. I noticed that it asked me to unmute, but I wasn't certain if that was an error earlier. Yeah, Dr. Shea, I really enjoyed your talk today. I really appreciated hearing your stories. It reminded me a lot of reading Dr. Mary Guylard's autobiography she wrote as being one of the first women faculty at UC Berkeley Physics. And I was typing this question right when you said actually that you were planning on writing a book. And I just wanted to say that I really want to read that book. I think it would be really enlightening for especially women in space physics. There's so many coming into the field these days, and hearing your experiences and how you got into it, how you got through it, I think would be really, really wonderful. And also, I really love your papers on SEP connectivity in the Carrington event from 2003.
Fantastic.
Oh, yes. I remember those papers on the Carrington event. That was a fascinating event to study. Right now, actually, my husband and I don't know where I lost my figure, but I've lost something here. My husband and I are writing a paper with, of all people, Ken McCracken. He is now in Australia, and we're writing a paper on the February 1956 event, which was pre-IGY. And we're still interested in solar physics.
That is fantastic. Yeah, my dad was a physicist and he worked all the time. So,
I see a message down there from Judy Coppin, and I remember visiting her at NRL too. It's nice to see some of these people that I remember listening to me.
So you see another Judy also. Great for coming, Judy. We want books. We want your memoir. We have a question from Andrea Osho Cordova. You can unmute and ask, or I can just read it. Andrea,
I can't unmute easily here.
No, I'm saying maybe Nick, can you unmute Andrea Osho? Oh, great.
Okay.
Yes, you want to ask your question, or I can read it.
You hear me?
Andrea is there. Yeah.
Yep.
Yeah, can you hear me?
Yes.
I hope you can understand me because I am a little sick right now.
No, totally. We understand you. No problem.
Okay, first of all, I would like to thank Peggy and you for this talk. It was very enlightening. And I have a couple of questions. The first one is, which is your favorite part about working on space physics as a field? And my second question is that if you could look back to when you were starting your career as a researcher, is there something that you would have done differently, or something that you could prefer to, I don't know, have a little more of guidance?
Mara, would you please repeat that? I didn't quite get it all.
The question that Andre is asking is the first part, what was your favorite part on working in space physics? And the second piece was, if you would go back to your beginning of your career, would you have done anything differently?
Ooh. I'll take the second question first.
Sure.
I honestly don't know, because when I started in physics, I didn't know where I was going to go, but I was determined I was going to at least a bachelor's degree in some worthwhile science. My father had encouraged engineering, and I wasn't particularly interested in engineering. I thought I might switch into chemistry, but I found physics a little more interesting than chemistry. So
Can I ask you about this piece, Peggy? It's pretty unusual for the fathers to have, right, at that time, encourage you to be an engineer. Where it came from? Do you know?
Well, he encouraged me to be engineer and going into engineering because it was a career in engineering, and he didn't see a career in physics.
Okay.
I can tell an interesting story about him, and that was that the Sunday newspapers in those years had a comic strip called Buck Rogers, and he often would look at it and say, "Oh, well, that's all pie in the sky. Nobody's ever going to go up into space." And of course, that I'm talking about the 1940s when that was a popular comic. So it's hard for me to look back to say whether I would have done anything differently. I use the expression, I was in the right place at the right time. And when Sputnik went up and space became a viable place to do some research, it was brand new. I was already working part-time, and I just sort of flowed along with the crowd at that time.
Fantastic.
I don't have any other.
I have a
career.
follow-up question regarding that, and maybe I don't want to hog the questions. If somebody else have a question, I can hold back mine. So I would start the question, but if anybody else want to raise their hand and ask, please do. In terms of mentors, Peggy, I know you talked about a lot of your support of even your husband and your colleagues that you encounter early on. But the other question we're always interested is how you find mentors and how you go, especially when you don't, you as you said, one of the first female researchers, when you look around, how did you found your mentors?
Well, again, I stumbled into it. Ken McCracken visited the University of New Hampshire. He was interested in getting the neutron monitor data for those 1960 events. And we hit it off. He had this computer program. I talked to him about the events, and he just ultimately became a mentor. Hugh Carmichael was someone else. In most cases, I was treated very nicely by the cosmic ray community, and I wasn't looked down at, except when those people at the presentations decided that they would just negate some of the work I was doing. I know that one of those individuals was very anti-women, and I saw it later on in other respects. So I just had to shrug it off. There were not women scientists in that day and age that in the space community that really could be a mentor. I knew Virginia Lincoln, and she helped along the line, helping me with data. But Helen Dobson Prince was another wonderful person to work with, and she was definitely older than I, and she was a mentor too. But I didn't go out looking for mentors. I would also say that the cosmic ray community is extremely friendly. and they're, for the most part, they all really go out of their way to help a colleague. That is maybe just the way the community works. And I'm happy to be in that community. I know other communities
That
are
are
not
less
that
so,
way.
right, right. And I think what you're describing that I thought was also super interesting, the amount of sharing that you guys did early on
Yes.
that is super unusual in so many communities is not like that. Yeah. And the other comment you had, I experienced that myself, but it's interesting to see the next generation, this capability of shrugging it off. And some people are more sensitive than that, so they need more mentors. But that capability to ignore certain behaviors of biases is yeah, sometimes it's needed, something like that.
I'd like to mention one more thing, Robin, and that was
Please.
John Wilcox.
Yeah,
He was at in California, the Wilcox, well, that's now the Wilcox Observatory, but John once mentioned to me, he said he had noted that there were not many women, not any really, who had been either chairman of sessions at the AGU or had been invited to present papers as an invited speaker at the AGU, or even other roles, committees and so forth. And so he said he was going to try to do something about it. Now, there was a case of a man who saw a problem. He went to the AGU people and he was in a leadership role. And I think though he never said anything, I think he must have really pushed to have women recognized. Shortly thereafter, women started to be listed as chairman of sessions. They were being included on the different programs. So sometimes that's all it takes is one person to see a problem of a bias in any direction and then quietly try to see if they can change the situation. And they certainly did.
Yeah, I wholehearted. I experienced that myself, and I saw other cases same similar. You need one person in the one or two, they can really change the needle if they see a problem. We hope there will be less than that. We hope that the next generation will need less, but it truly is right. I agree. Folks, we're coming on almost to the end, but I was told that there's another question. So
I think Abdullah had his hand up, but then it went down again. So I've given him permission to them permission to speak. So Abdullah, if you have a question.
Hello.
hi, Abdullah.
Hi. Thank you, Peggy, for this amazing talk, and thank you for sharing your distinguished experience. So I have a question. If we want now to compare our new days with the old days, do you think that the science, or not that the community is becoming less biased or unbiased at all toward a woman or man achievements or engagement in science activities?
That's an interesting question.
As far as women are concerned, I think there has been a definite change from when I was starting out. I don't know, I can't speak for the other types of communities, such as the racial or other types of communities, because I really don't know. I do know that I've just looked upon science as scientists. I don't really care myself what their background is or where they come from. I've co-authored papers with people from over 20 different countries. And one thing that I have certainly learned when I've been traveling is to understand what the country ethics are, what the culture is, and try to work with people all over the world. So probably I'm not a good person to ask this because I see it all the time. I see more women. I see people, other people. I don't really know how it is progressing. There is still certainly bias there. I have no question about it. But I think there's less of it now. At least I hope there is.
Abdullah, great for the question. This is part of the motivation behind our broader impacts in SHIELD and the other drive centers to try to move the needle even faster. There have been progress, but there is ways to go in many ways. Howard, you had a question. You want to close up?
Yeah,
Yeah.
well, I'm not sure to close, but I want to, can you hear me?
No, absolutely.
Okay. So I just wanted to thank Peggy also for this great talk. But what I wanted to mention was she's mentioned about all of these international collaborations. And I overlapped with Peggy for about 12 years at AFG, Air Force Geophysics Laboratory. And there was always a stream of international and national people coming through who were working with Peggy and Don. And that really enriched our environment at the Air Force Geophysics Laboratory. So I just wanted to mention how important that was and to thank you for that, Peggy.
Well, thank you very much, Howard. I know I remember working with you and enjoying it also.
Thank you.
Fantastic. Folks, we gotta close up. It's top of the hour. Peggy, you want last words to say? And
well, I wanted to thank you again for letting me have this opportunity. I'm sorry that we seem to have a problem with the Zoom partway through it, and I apologize for it. I think it was probably all on my end, although I do see a lot of
don't worry. No, I
those
don't
things
think
happen.
so. Yes.
And anyway, if anybody wants to contact me, contact Mara for getting my email address. I share it with anyone, and I'm certainly willing to continue the conversation offline or by email. And
come back.
Again, if I ever write the book, I'll let you know.
Yeah, come back to tell us about the book. Okay, bye folks, and see you in the next webinar with Maura Hagen in March. So
Thank
hope
you.
to see you all there. Bye folks.